we were taught the first 3 minutes of Big Bang produced nothing but an expanding ocean of pure hydrogen and helium. Heavy elements like nitrogen were supposed to take billions of years to slowly forge inside ancient stars. But as of early 2026, that timeline has been violently derailed. The James Webb Space Telescope just locked onto MOM Z14, a blazing galaxy existing a mere 280 million years after the universe began. According to the math, this environment should be absolutely pristine. Instead, Webb detected massive, blinding spikes of heavy nitrogen, the chemical ashes of dead stars. Are our elemental models fundamentally flawed? Or did the early universe trigger a wave of supermassive detonations the second it was born? Today, we reveal the impossible chemistry that just broke the Big Bang timeline. Let's start by understanding a law known as Big Bang nucleosynthesis. When the universe violently expanded into existence 13.8 billion years ago, it was infinitely hot and infinitely dense. But as it expanded, it cooled. Within the very first 3 minutes of creation, the universe hit a critical temperature that allowed the first protons and neutrons to bind together. But this cooling window was incredibly brief. The universe was expanding so rapidly that after those first 3 minutes, the temperature dropped too low for any further complex nuclear fusion to occur. The oven was turned off. Because of this strict 3-minute time limit, the Big Bang was only capable of manufacturing 3 things: a massive ocean of primordial hydrogen, a smaller amount of helium, and a microscopic, almost negligible trace of lithium. In astrophysics, every other element on the periodic table, carbon, oxygen, iron, silicon, and specifically nitrogen, is classified as a metal, and the absolute unbreakable law of the Standard Model is that the Big Bang could not make metals. To forge these complex elements, the universe had to wait. It took billions of years and multiple generations of stars living, burning, and violently dying in supernovae to slowly pollute a galaxy with the heavy metals needed for planets and life. The cosmic cook time simply cannot be rushed, or so we thought, when an international research team led by MIT's Dr. Rohan Naidu pointed the James Webb Space Telescope at the deep field anomaly known as MOM Z14. They engaged a highly specialized instrument called the Near-Infrared Spectrograph, or NIRSPEC. They weren't just taking a picture, they were scanning the light to read the exact chemical barcode of the galaxy. Because MOM Z14 sits at a confirmed redshift of Z equals 14.44, we are seeing it exactly as it existed a mere 280 million years after the Big Bang. In the rigid, unforgiving mathematics of stellar evolution, 280 million years is mathematically zero. The evolutionary clock of the universe had barely started ticking. The researchers expected NIRSPEC to return a perfectly pristine barcode. They expected to see a virgin galaxy composed entirely of the pure hydrogen and helium left over from the Big Bang. Instead, the spectrographic data returned an impossible signature. Blazing across the readout were massive, undeniable emission lines of heavy nitrogen. The researchers were staring at a chronological paradox. How can a galaxy barely out of the cosmic womb be completely choked with the chemical ashes of dead stars? There physically was not enough time for a first generation of stars to form, live out their lifespans, die, and seed a second generation capable of producing this much nitrogen. To understand why this breaks the timeline, we have to look at a concept known as the missing generation paradox. Theoretical physics has long predicted the existence of the universe's very first stars, known as population 3 stars. These theoretical stars were supposed to be massive, pure hydrogen and helium engines. Because they had no heavy metals inside them to help regulate their fusion, they would burn incredibly hot and bright. But the key to the population third theory is that they were supposed to gently and slowly seed the universe with the very first trace amounts of heavier elements. They were the bridge between the pristine Big Bang and the polluted modern universe. MOM Z14's nitrogen levels indicate that the universe completely skipped this expected evolutionary step. This galaxy is not gently transitioning. It is operating with the chemical maturity and metallic pollution of a stellar system that is billions of years older. It proves the universe didn't slowly transition from pristine to polluted. It was violently saturated with heavy metals almost instantly. The discovery implies that our models are missing an entire generation of explosive stellar evolution that must have happened in the absolute, pitch-black dark immediately following the Big Bang. To explain this impossible chemistry, astrophysicists are being pushed to the absolute edge of theoretical physics. They are being forced to completely rewrite how the first stars operated, proposing a terrifying new mechanism of creation known as the supermassive engine theory. To generate the specific, massive nitrogen spike observed in MOM-Z14, you cannot rely on standard stellar fusion. You need a highly specific, aggressively fast nuclear reaction known as the CNO cycle, the carbon-nitrogen-oxygen cycle. In the CNO cycle, a star uses trace amounts of carbon as a catalyst to fuse hydrogen into helium. And in the incredibly violent process, it churns out massive amounts of nitrogen as a byproduct. But the CNO cycle requires terrifying core temperatures to operate at the scale required to pollute an entire galaxy. Researchers theorize that the environment of the early universe, specifically inside MOM-Z14, was so incredibly dense and tightly packed that it forced the creation of monster stars. We are not talking about stars slightly larger than our Sun. We are talking about stellar behemoths containing between 1,000 and 10,000 times the mass of our solar system's star. These supermassive population 30 monsters would have dominated the early void. Because their mass was so extreme, the gravitational crushing force on their cores would be almost incomprehensible. This pressure would trigger the CNO cycle on absolute overdrive. But the defining characteristic of a star this massive is that it cannot survive. A star with 10,000 times the mass of the Sun burns at temperatures that are fundamentally unstable. Instead of living for billions of years like a normal star, these monsters would burn through their entire nuclear fuel supply in a fraction of a cosmic second. Astrophysicists estimate these behemoths would live for only 250,000 years. In the timeline of the cosmos, that is a microscopic blink of an eye. They lived incredibly fast. They died violently, and they blasted massive quantities of nitrogen into the void at an aggressively accelerated rate. When these monster stars detonated, they didn't just fade away, they collapsed directly into massive black holes, ripping their outer layers apart and permanently altering the chemical makeup of the early universe. This terrifying mechanism is the only way to explain the Webb data. It is the only way to mathematically force that much nitrogen into a galaxy that is only 280 million years old. But accepting this theory means accepting that our fundamental understanding of the Big Bang's aftermath is broken. For decades, the Standard Model painted the early universe as a slow, expanding soup of simple gases, taking eons to patiently organize itself into the complex structures we see today. The Big Bang was treated as a singular explosion followed by a long, quiet cooling-off period. The nitrogen anomaly in MOM-Z14 proves that the early universe was not a quiet, expanding soup. It was an ultra-compressed, high-pressure crucible. The Big Bang theory isn't necessarily wrong about how the universe started in those first 3 minutes. The hydrogen and helium base layer is still there. But MOM-Z14 proves that our timeline for what happened next is completely, hopelessly broken. The universe did not wait billions of years to manufacture the chemical building blocks for planets, complex structures, and eventually, life. It aggressively manufactured them almost immediately. The James Webb Space Telescope was built to look back in time and confirm the models that physicists have spent decades building. Instead, it is actively dismantling them. With every new spectroscopic barcode pulled from the deep field, Webb is proving that the universe is far stranger, far faster, and far more explosive than we ever imagined. Like, subscribe, and hit the bell to ensure you never miss the latest deep space paradoxes as they are pulled from the raw data.